Hello and welcome to this session where we are going to talk about energy storage or batteries on board in vessels. So I hope you will have a bit more knowledge around batteries, why we use them and what we need to be able to sell batteries and what are the benefits from the batteries on board a vessel. Okay, there are several different reasons why ship owners would like to have a battery on board. And we will talk a bit about these different reasons, and we will talk a bit about what do we need to calculate and to find the correct sizing of the battery. I think you will benefit more from this session if you have been through the other sessions around the electric systems and such. But anyway, we will explain some details in this session as well. So let's start with full battery. And by full battery, I mean it's a battery only. It's a vessel with no fossil fuel on board. No diesel, no gas oil. And this may be a ferry. In Norway, we already have ferries with battery-only installation. Ferries crossing a fjord, not a too long distance, let's say below half an hour as a rule of thumb. And if you have a sailing distance below half an hour, then you can easily have a full battery ferry. And you will then have typically two electric driven propellers. For a double-ended ferry, you will have one propeller in each end of the ferry. And these two electric motors are frequency converter driven, frequency drive. So one frequency drive for each electric motor. And we have a switchboard distributing the power for the propulsion and as well for the rest of the hotel load on board. For redundancy reasons, it may be that you would like to have two battery packs providing energy for the network. And with this as a typical installation, you have 60 Hertz or maybe 50 Hertz for a ferry. It's could be 50 Hertz as a typical voltage for the hotel, and then you pick and choose 50 Hertz on the grid, no problem. And you have stable 60 Hertz for this setup at least, and you have 0 to 60 Hertz on the electric motors to be able to regulate the RPM of the propeller. Batteries, they are DC, so we need a frequency drive in between the batteries and the switchboard to make the 60 Hertz. So we take DC, make 60 Hertz, then we use a frequency drive as explained in one of the other sessions, and make a frequency where we can regulate the frequency. With a solution like this, full battery, it's obviously that you need something that charged your batteries, and that is typically done by some sort of charging equipment from shore. When this ferry is at shore, you need to charge the batteries, and you may have a limited time to charge due to the fact you are only offloading and unloading cars and passengers. So a very limited time frame to charge, and then you are sailing, let's say maybe half an hour. So to understand the battery and how we design the batteries, you need to have a look at the actual installation on board. Let me make a quick sketch of how the battery will operate for a ferry like this. So let's say this is a full battery, and I'm going to draw here the duty cycle. Okay, so let's indicate this is a ferry. It is excuse me. It is sailing half an hour from shore to shore, and it is maybe at shore for, let's say, 10 minutes. Discharge and charge cars, offload and unload cars and the passengers. So your battery will then be charged and will be, let's say, fully charged up there. The battery is fully charged, and we will start half an hour sailing. So during half an hour you will discharge the battery. Let's say this is empty, so you will discharge the battery for half an hour. And then you are approaching the shore and you are charging, and you know, in this case we have said 10 minutes for charging. I know it's maybe a bit short, but something like this, 10 minutes. And during those 10 minutes you have to charge all the way to fully charged again. Then you have another half an hour and another 10 minutes. Discharge for the next trip and then charge again. I've said that you need to understand the duty cycle for a battery in order for us and for our engineers to design and calculate the size of the battery. This is at least the basement that we need to understand a bit of the duty cycle. Because this way of utilizing a battery is quite heavy. This is a hard life for the battery. It is heavy discharge and even more heavy charging, really quick charging, and then discharge and charge, and throughout one day with a cycle like this you have really stressed your battery quite heavily. Charging and discharging will of course make heat inside the batteries, and you will have losses during this process as well. So for a full battery ferry, you will have perhaps a picture like this. For this ferry, we see today as well that some of these installations, they would like to add generating sets, one or more generating sets, to be able to move the ferry, to be able to have some backup in case failures on the battery side. So then you have a hybrid power providing. It's a hybrid because it's fuel and energy storage. The rest of the system, the transmission, is not a hybrid. That is a full electric. It's a full electric transmission, but it's hybrid on the energy side. So what is the rationale behind having a full battery? I think that's quite clear. It is to avoid local emissions, to avoid exhaust noise. It may be different reasons for that, but mainly it's for having a vessel running full battery. So by an installation like this, you have a vessel that is fully charged from shore, and all the duty is done based on battery and energy storage. Could be that you could have a small harbor tug as well, just operating inside a harbor, charging when it's resting at shore, and then doing his job fully on battery only. Small inner harbor jobs. That may as well come. But for the time being, the energy density for a battery is so far away from the energy density of a fuel, let's say LNG or heavy fuel oil or diesel oil. The energy density in fossil fuel is so much bigger than in a battery. So for a long distance sailing, we are still not there that we are able to have a full battery installation. It will be very, very big batteries if you want to go for a long distance on battery only. Okay, but let's have a look at other solutions as well. I think I would like to at least indicate our Save Cube solution with battery. So again, have a look at one of the other sessions where we present the Save Cube, but the cube will then have internal DC, so we can connect the batteries directly to the DC. No need for any frequency drive in between. And on the other side, we only need the inverter to make the 0 to 60 Hertz frequency for the motors. So with the cube, this is then a cube, as we have explained in one of the other sessions. So with a cube for a full battery, you avoid some steps of converting. You do not need to convert your DC into the switchboard. Then you have DC, and you only have to convert the DC to the frequency you need to control the motor. However, as explained earlier in another session, you need an inverter to the hotel load. So let's say you need 230 volt, 50 hertz for the hotel, then you need an inverter for that load. But this is a really good solution for a full battery, because you avoid losses in several steps of frequency converting, because you can have your energy storage directly connected to the Cube DC system. So this is a good solution for energy storage solution as well, the same Cube. Okay, so we have said and started with a reason why we have batteries. So I will write full battery. Battery only, or full battery. You may have a small genset, as we said, into the installation as a backup, but still you are planning to have a full battery duty, and then it will look like something like this. Okay, but you may have another reason. Load smoothing. You may have heard this expression, to have load smoothing, that your battery can smooth your load from the engines on board. And then your system would probably look like this. You will have frequency drives and a typical switchboard, fixed 60 Hertz, and you will have, let's say, a very typical diesel electric setup with 4 generators and 4 diesel engines. And then the rationale behind is that when you are able to really flatten out your load on your diesel engine, you would probably save a bit fuel. So let's have a look at the load if you have such a situation. Your engines are providing the power for your network, your entire hotel load and your propulsion system. You may have several more propellers than just 2, you may have 4, 5, 6. Anyway, your engines are providing power for the complete load, and your power or your load will most probably be fluctuating up and down, and you will have some spikes, and it will work something like this perhaps. And what we then think of when we say load smoothing is that the diesel engines will not see this load picture, even though you have this load picture, but your engine will be stable loaded, and your battery will then be discharged, charged, discharged, charged, discharged, and so on. So your battery will then provide energy during these load spikes in the net, and will give your engines a possible flat load. Okay, this is something that you would probably believe will give you some fuel savings. However, we have done some tests, and it doesn't look like this is really a fuel saving that you will benefit from investing in a battery. So I mean, investing in a big battery only to be able to smooth your load is probably not worth the money, because the fuel savings just to smoothen the load will be very, very small. In fact, with our frequency drives, we have a possibility for the captain to push power mode on the frequency drive, and the power mode will give constant power on the switchboard. Quick explanation of that. Normally you regulate the RPM of the propeller by the lever on the bridge. And when you control the RPM, you say to the propeller by your lever, keep this RPM. Let's say 50% RPM by your lever. Okay? Then you will have 50% RPM on the propeller, and you will have that as a stable frequency from the frequency drive. Stable 50% of the frequency. But when you are then sailing in waves and current and wind, you will need different fluctuating power. Your power will fluctuate to be able to keep the RPM constant. So if you have put your lever at 50% thrust, you will have 50% RPM, and your load will be like this on the grid. So your engines need to cope with that. But as I said, we have a setting in all our frequency drives that is called power mode, and that is something the captain can use. And when he pushes the button power mode, his lever will then not ask for RPM, but he will ask for power. So when his lever then is at 50%, he will ask for 50% power. And then the RPM will be whatever needed to give 50% power. The frequency converter will then make sure that the pull, the power pull, the load from the switchboard will be constant, 50%, and it will regulate the frequency on the propeller side to always give fixed and stable power. And then suddenly you have a stable power on the switchboard without any battery at all. So, I mean, we still have this we have this function already in the frequency drives, so you can utilize at least when you are sailing. It's a bit hard to use power mode when you are maneuvering, because if you look at the propeller curve, your power is at the end coming very quick and very fast, so it's a bit more difficult to maneuver. So in maneuvering in harbor areas and stuff like that, you should go for RPM mode and control the RPM by the lever, because then your maneuvering is a bit more easy. But for all the sailings, when you're sailing in a distance, you can push power mode and your load will be stable for the diesel engines. So, okay, load smoothing is probably not really the rationale behind adding a big energy storage on board a vessel. However, the next step would then be peak shaving. And when we say peak shaving, then we are suddenly into a picture where we are able to stop one of the engines due to the battery installation. I will try to explain to you. If your max continuous rating of one engine, MCR, max continuous rating of a diesel engine, let's say it's there, and your load on the network is increasing and it's close to max continuous rating of one engine, then you need to start up your second engine in a normal diesel electric installation. You need to start the second engine so that you have more power available. However, it may very well be that your load will just go above the max continuous rating and it have some spikes just to start something. So then it feels a bit wasted to start another engine just for these small spikes. And it is a bit wasted because then suddenly you will have two engines running at more or less half load only because you're close to the max continuous rating of one diesel engine. If you have a situation like this, then your battery will easily cover these areas. Your battery can easily take the load on the spikes, the peaks of the load, and you can stick with one engine. So peak shaving, that is a good rationale behind having a battery. If you do your calculations correctly and you see at the complete picture that you will end up in situations like this quite often on board the vessel. And if you're then able to run your vessel with only one engine, or at least one engine less than you else would have needed by having a battery on board, then you suddenly understand that you will save fuel from not starting that second engine. You will save running hours and maintenance from not starting that second engine. So peak shaving is of course a good reason why having a battery on board a vessel. But again, you need to study your complete setup and see if it makes sense, if you will end up in situations where you are close to the MCR. Our engineers can help you with that. So just dig out as much information as possible from the customer. Okay, then we have maybe let's say a bit about safety backup battery. So let's just call that safety backup redundancy. That may very well be a rationale why you would like to have a battery on board as well. That is because for a dynamic positioning vessel or a redundant propulsion vessel, there are requirements that you are not allowed to sail or be in operation with only one engine running. So the rules and regulations will require you to have at least 2 engines running, even though you don't need 2 engines based on the load. So by having batteries for safety or redundancy backup, then you as well are able to run your system with 1 engine less. So, I mean, just to indicate, if you then have stopped 3 engines, and this engine will cover the whole load, in case something happens with this one, you will then have the battery as a safety backup. If you didn't have the battery installed at all, then you would have to run 2 engines. So again, the savings are obvious in this situation because you're running only 1 engine. And the situation could be that you were running 2 engines at half load. Not good for the engine. But that once you add the battery, you will be running 1 engine at almost maximum load, and that is a much healthier duty for the engine, fuel savings and combustion and everything, and your battery will be a safety backup. Just remember that this safety backup has a time limit. Engine doesn't have the same time limit. So just be aware that there may be time limits that you need to know about and to discuss with the regulations, the class societies and the owner when you do it like this. But the savings, they are quite obvious at once you are stopping 1 engine due to the fact that you have a battery on board. So for peak shaving and safety backup, you are able to stop 1 engine in some cases, and again that is really a situation where you are able to save some fuel on board. Okay, then I would like to put up maybe another phrase here. Plug-in hybrid. Because there are another reason as well. There may be several reasons for having a battery on board. And what we have seen from some ship owners is that they would like to have a battery to run their vessel at full battery for shorter time of period. They need their engines to be able to do all their tasks. However, they would like to have a battery to be able to sail, let's say, a short distance in and out of harbor. close to the city center on battery only. At once they have left the city center, maybe after half an hour, then they will start up their engines and they will sail for, let's say, half a day or whatever, if it is a RoPax or a Ro-Ro or something like that, or a cruise vessel. Then they can sail for half an hour close to the city, close to the harbor, on battery only, and then on the engines when they are out in the open sea. That is one situation. Another situation can be that they have a cruise vessel and they would like to sail for 1 hour, 2 hours, maybe, on battery only. Maybe when they are idling in an area where they would like their passengers to go outside and look at the view and study the nature and just enjoy the silence, no exhaust, no vibrations, no noise, and just enjoy the passenger experience. That may be as well. And even mega yachts and yachts perhaps are looking for batteries to have some hours during the day in complete silence, but still have propulsion power to move the vessel, still have power enough for the hotel load. So there may be different rationale behind these. And this type of installation we may call plug-in hybrid or partial full battery, because they are full battery in parts of the sailing. And again, if you have a plug-in hybrid, of course, whatever energy you get from the shore, from the grid, that is probably clean energy, or at least it's coming from the grid. But whatever energy you have to produce on board, charging the battery, and then you're spending the energy on the load at a later stage, all that energy will be produced by fuel, and you have losses into the battery and you have losses out of the battery again. So there is no really fuel savings in producing the energy by your engines in that way. But if you have the plug-in hybrid, you may utilize that for safety and for peak shaving. And then suddenly you have an installation where you can play a bit around with the battery, and you may stop one engine due to safety requirements or due to peak shaving. And then suddenly you're able to save fuel, save maintenance, because you have stopped an engine. So again, you need to have a look at the duty of the vessel and why you really would like to have a battery. And of course, it doesn't have to be a full electric transmission vessel. It may very well be that you have a big engine with the gearbox and the shaft and the main propeller and a generator motor like an HSG, as we have discussed before, with the frequency drive in between the switchboard and the motor. So again, then you can stop the main engine, you can run your propeller from the auxiliary engines or from the battery, and you can charge the battery from the main engine and you can use it for the propeller. And you may even have twin screw with 2 propellers. So it will give you the same functionality if you have this type of hybrid shaft installation. So just remember, you may have a plug-in hybrid, partial battery driven vessel, partial full battery driven vessel. It will not save very much fuel. it will save fuel if you plug in to the shore. Well, then you will save some fuel because you are charging from shore, but the rest you need to charge from your engines, and then it's not really fuel saving. But if you introduce for safety reasons or for peak shaving, then suddenly you will save some fuel. Because if you have a look at a vessel starting at A and sailing to B, close to harbor, close to city center, maneuvering, you can go battery only. Then you start your engines and you sail. Then you stop your engines and you go battery only back to shore. So battery close to the harbor and battery close to the harbor on the other side. Sailing will be done by fuel oil. So I mean, you charge when you are at shore, you utilize the energy you charged from shore, but when you're sailing, you need to recharge your batteries again, and then you charge your batteries from your diesel engines, and then you discharge your battery again when you're maneuvering into the next harbor. Then you need to plug in again and charge. And with this setup, half of the battery energy will come from shore, half of the energy will come from fuel oil on board. So again, you need to understand the sailing, the operational duty of the vessel. Okay, I made this diagram for the full battery duty cycle. It's a hard, tough life for the battery. And it's important that you understand the battery duty on board for us to be able to calculate. If you have a battery that is only going to be some sort of battery backup, safety backup, redundancy backup, then you have a battery that is fully charged day out and day in. It may be fully charged for months, and then suddenly you have some sort of failure where the battery kicks in and will be discharged. And then you have to charge your battery back. That can be done quite slow, and then you are sailing again for months. So before this happens, it may go several months, and this may happen maybe twice a year. And this is a totally different life for the battery. If this is 1 year and this is only 1 hour, you see the difference? This battery is discharged, charged, discharged, charged several times for 1 hour for a ferry. This battery is discharged and very slow charged again once or twice a year. That is a totally different life for the battery. And this is something we need to know. Our engineers need to know this to be able to design the battery. You can of course say that this is 1 megawatt hour and that this is 1 megawatt hour, but the battery sizing will be totally different. And again, how long do you want the battery to last? If you want your battery to last for 5 years, well, then it will be a totally another type of battery than if you want your battery to last for 10 years. That is a calculation. If your customer asks us for a battery that he would like it to last for 10 years, okay, then we need a larger battery pack so it can withstand all the discharging and chargings for 10 years. If he wants 5 years, then it will be a smaller investment, a smaller battery, smaller space. If he would like 3 years, maybe he expects the pricing of the batteries and the size of the batteries will be better within 3 years from now, so we just want to look for a 3-year lifetime of the battery. Well, that's okay, we can calculate that as well. So that is a calculation. So it's important, if we need 1 megawatt hour for this battery and we need 1 megawatt hour for this battery, it may very well be that this installed battery will be twice as big as this one. Perhaps, dependent on lifetime and other factors as well. But it's important that you understand how this works when we are calculating a different type of batteries. And if you have a battery for safety, backup, like this one, you can of course as well do peak shaving on top of this. So make it capable of doing some peak shavings, and that will add some parameters to the calculation. If you would like your battery to be only peak shaving, then we may have a much smaller battery. So this is all is dependent on the load and the load picture and the duty of the vessel and the battery. So just remember the different ways of utilizing a battery. You will probably ask me now, what about harvesting energy from a winch, from a crane and stuff like that? Well, that is fully possible. It's possible to harvest energy from an electric winch, electric crane, and to put all that excess power or regenerated power back to the battery. It's just a part of the design of your system. If you have a winch and you want the energy made from the winch regenerated back to the battery, that's of course possible. You just need to plan when you are sailing. You need to plan for having an empty battery when you start regenerating power, because you need an empty battery to be able to put energy back onto the battery. So stuff like that needs a bit more planning when you are utilizing the battery, but it's of course it's a fully possible solution as well to harvest the energy from a winch, from a crane, from another equipment that really you have to break, because then you break the equipment by charging the battery. Okay, that was a very quick introduction to energy storage and battery solutions. But you have a good group of people inside Rolls-Royce that are dealing with energy storage. So please ask, and now you have a small understanding, I believe, of different ways of utilizing the battery and what our engineers are looking for and asking for. We need to know a bit more about the duty cycle. How is the battery intended to be used? We need to know a bit around that. We don't need to know everything, because we may just bring in our own experience and give some suggestions to the customer. Of course we can do that, but as much as possible will make it easier. Okay, hope that could be useful for you, and thank you for listening to this session as well.